Isaac Newton understood the concept of inertia developed earlier by Galileo. He knew that without an outside force, moving objects continue to move at constant speed in a straight line. He knew that if an object undergoes a change in speed or direction, then a force is responsible. According to legend, Newton discovered gravity while sitting under an apple tree. Newton saw the apple fall, or maybe even felt it fall on his head. Perhaps he looked up through the apple tree branches and noticed the moon. He may have been puzzled by the fact that the moon doesn't follow a straight line path, but instead circles around Earth. He knew that circular motion is accelerated motion, which requires a force. Newton had the insight to see that the moon is falling toward Earth, just as the apple is. Newton realized if the moon didn't fall, it would move off in a straight line and leave its orbit. His idea was that the moon must be falling around Earth. So the moon falls in the sense that it falls beneath the straight line it would follow if no force acted on it. He hypothesized that the moon was simply a projectile circling Earth under the attraction of gravity. This original drawing by Isaac Newton shows how a projectile fired fast enough would fall around Earth and become an Earth satellite. Newton compared motion of the moon to a cannonball fired from the top of a high mountain. If a cannonball was fired with a small horizontal speed, it would follow a parabolic path and soon hit Earth. Fired faster, its path would be less curved and it would hit Earth farther away. If the cannonball was fired fast enough, its path would become a circle and the cannonball would circle indefinitely. Both the orbiting cannonball and the moon have a component of velocity parallel to the Earth's surface. This sideways or tangential velocity is sufficient to ensure nearly circular motion around Earth rather than into it. With no resistance to reduce its speed, the moon will continue falling around and around Earth indefinitely. Tangential velocity is the sideways velocity, the component of velocity perpendicular to the pull of gravity. For Newton's idea to advance from hypothesis to scientific theory, it would have to be tested. He reasoned that the mass of the moon should not affect how it falls, just as mass has no effect on the acceleration of freely falling objects on Earth. How far the moon, or an apple at Earth's surface, falls should relate only to its respective distance from Earth's center. The moon was already known to be 60 times further from the center of the Earth than an apple at the Earth's surface. The apple will fall 5 meters in its first second of fall. Newton reasoned that gravitational attraction to Earth must be diluted by distance. The influence of gravity should be diluted to 1/60th of 1/60th. In 1 second, the moon should fall 1 over 60 squared of 5 meters, which is 1.4 millimeters. Newton calculated how far the circle of the moon's orbit lies below the straight line distance the moon would otherwise travel in 1 second. His value turned out to be the 1.4 millimeter distance accepted today. He was unsure of the exact Earth-Moon distance and whether the correct distance to use was the distance between their centers. It wasn't until after Newton invented a new branch of mathematics, calculus, to prove his center of gravity hypothesis that he published the law of universal gravitation. Newton generalized his moon findings to all objects and stated that all objects in the universe attract each other. No longer was Earth considered to be the center of the universe. It became clear that the planets orbit the Sun in the same way the Moon orbits Earth. Planets continually fall around the Sun in closed paths. The tangential velocity of Earth about the Sun allows it to fall around the Sun rather than directly into it. What would happen if the tangential velocities of the planets were reduced to zero? Their motion would be straight towards the Sun and they would crash into it. Any objects in the solar system with insufficient tangential velocities have long ago crashed into the Sun.